Alright, let's carry on with harmonics. Now we go to the another aspect. So we just learn how to find RMS, VRMS from this sinusoidal expression, right? This voltage signal here that has a mixture of DC and AC of different frequency. We know how to find the RMS voltage, right? And if I give you the current expression, you also can find the RMS current. You can find the true power using VI cosine theta concept, and you can use power factor. You can find cosine theta also, which is the power factor is equal to P divided by S. So now let's talk about another aspect of it, is that I give you an AC circuit and I give you the impedance. Right? So if I say this is equal to 3 ohm, this is equal to a 4 millihenry, is 6 microfarad, right? Then I say, okay, this is my V, this is my voltage, and I would like you to find me the expression of this current. Then what must you do? Now we are going to learn is that this one, because this voltage, right, has actually got a few components. One, DC, first harmonic, third harmonics, and the fifth harmonic. Alright? Now, if you recall in your first year AC, right, if I were to tell you that this is equal to 50 Hertz, are you able to get me the impedance of this circuit? You should have no issue, right? You say it's equal to R plus JXL minus JXC. Right? And then you say, oh, okay, 3 plus J, 2 pi FL minus J 1 over 2 pi FC. Right? And you substitute all the value. Frequency is given as 50, so you multiply 50, and 4 milli, so it's 4 times 10 minus 3, minus J 1 over 2 pi times 50 times 6 times 10 power minus 6. Right? So you get this complex number to find the impedance. True? So with 50 Hertz, I get this impedance. If I change to 150 Hertz, can you get me the new impedance? Of course you can. You just change the frequency to 150, right? You get a new impedance. If I say this is 250 Hertz now, can you get me another new set of impedance? Yes. Resistance no change because there's no frequency attached to it, but the rest, yes. So the frequency now is 250, you are putting in, 250 you are putting in. Correct? So to do this question, to find the current, you actually have to do your mathematics a number of times, depends on how many components you are given. So start off with the DC first. 10 volts is DC. So when it's due to 10 volts, that means this is now a DC, right? This 10 volt DC. Okay, what is the current? Now, if you remember in your AC that you learned in year 1, capacitor is fully charged, right? In the DC. Just like you charge your handphone, it's fully charged. So therefore, no more current passing through it. So in DC, capacitor actually acts as an open circuit. Right? So the current is therefore equal to 0 ampere. No current. No current. Okay, so we know already. So the current here due to DC, your IDC equal to 0 ampere. Right, next one. DC. Okay, so now due to your first harmonics. Your first harmonics is 141 sine 100 pi t. Okay, and you know that this signal, the frequency is actually 50 Hertz. 50 Hertz. So can you find me the impedance at 50 Hertz like what we did just now? You can, right? So it's R plus J 2 pi FL minus J 1 over 2 pi FC. You substitute the frequency of 50 Hertz, you get an impedance. Right? To find the current at this first harmonics, okay, which I call the fundamental. So it will be V divided by Z. V, remember, it must be RMS. So 141 divided by square root 2. What is the angle? 0 degree. Then you divide it by the impedance that you have found. Okay, at 50 Hertz. So you get an answer. You get an answer. Alright, so I1 you get an answer. Okay, now let me see in the book I have the answers or not. Okay, no, I don't have it. Okay, never mind. Let me just fake an answer. So let's say my I1, an example, is equal to 1.6 20 degree ampere. Okay, I fake one, may not be true. Do you know how to make these into sinusoidal expression? Of course you know. It's 1.6 times square root 2, that becomes Vp, right? And then sine 100 pi t plus 20 degree. That's how you convert polar number into sinusoidal expression. Vrms times square root 2 becomes the peak value, and angle, this is the theta. Okay? Right, so I have already done this one already. So this one we have done, this one we also have done. So now let's move on to this one. This one was the frequency. Third harmonic is 150 Hz. So now this is 42.3 sine 300 pi t. So the frequency is now 150 Hz. Can you do the new impedance? Of course. Substitute 150 times 150, you get a new impedance. The current now, due to the third harmonics, V divided by Z, the V is 42.3, right? Divided by square root 2, angle is 0 degree. Then you divide by your new impedance, right? Which is the third harmonic impedance. So you get a polar number. Again, let me figure an answer. So I3, let's say, is equal to 0.9, say 12 degree ampere. Can you make this into sinusoidal expression? Of course, 0.9 times square root 2 sine 300 pi t plus 12 degree. Right, so you get an answer. Then go on to this one, 500 pi t. So the signal now is 28.8 sine 500 pi t. And with that, the frequency is actually 250 Hz. So you find a new impedance again. This time you substitute 250, 250. You get a new impedance. Find a new current due to the fifth harmonics. V divided by this new impedance. So it's 28.8 divided by square root 2. Angle again 0 degree divided by the new impedance. So you get a polar number again. Right? So let me just pick another one. I find is equal to, let's say it's equal to 0.46 degree ampere. Do you know how to make this into sinusoidal? Of course. It's 0.4 times square root 2 sine 300 pi t 500 pi t plus 6 degree ampere. Right? So since my voltage signal has 4 values, 1, 2, 3, 4, you have to do this mathematics 4 times. Okay? After you have done that, then by principle of superposition, you add them all up together. So the IT is equal to the current contributed by this one, contributed by this one, contributed by this one, contributed by this one. So in other words, the answer that you have, you add it up by principle of superposition. So that is equal to 0 plus 1.6 square root 2 sine 100 pi t plus 20 degree plus 0.9 square root 2 sine 300 pi t plus 12 degree plus 0.4 square root 2 sine 500 pi t plus 6 degree. Right, so that's your current expression. Now once you have got this, if I ask you to find the IRMS, can you do? Of course you can. Can you still remember the expression? So that will be equal to 0 square plus 1.6 square root 2 divided by square root 2 square plus 0.9 square root 2 divided by square root 2 square plus 0.4 square root 2 divided by square root 2 square. Right? Ask you for the VRMS. Can do? Can. Like what we did just now. Similar. Yeah. Then the question carry on to find the total power using the VI cosine theta method. Remember, VDC, IDC, V1, I1 cosine theta, both must be RMS. V3, I3 cosine theta, both must be RMS. V5, I5 cosine theta, both must be RMS. Okay, then I say find me the cosine theta, the power factor. So that is equal to your P divided by S. P we already calculated. How to get the S? B RMS multiply I RMS. Right, and these two values we have calculated. So harmonic is quite a straightforward topic, especially when it's single phase. So far we only talk about single phase. I give you a voltage signal. Can you find me the current? Right? To find me the current, you actually have to do it multiple times due to the different frequency in my signal. Right? Do it a few times, convert them polar to sinusoidal and string them together. String them together. Okay? So be very familiar with your complex number. That's what our revision is all about. You know, our first video talk about complex number, how to convert inductance and capacitance to reactance. Yeah. Okay, that is harmonics all about. We still have a little bit more about harmonics.